Hassaan, thank you so much for joining me today.
Yeah, thanks for having me. I'm super excited.
Let's start with the fundamentals. Video generation, obviously, it has taken the world by storm. People are excited. People are doing so many things, which are, to me, 10 years ago was completely impossible unless you know some deep Adobe secrets. You can't do anything with video, but now it's amazing. So, can you walk us through how AI is being used to create these videos? What are the basics that we need to know?
Yeah, great question. So I think there's a few different domains, right? I think there's of course novel video creation, especially through large vision models and large image models, where now essentially you can have an idea, something completely crazy, and you can get a very good representation that essentially just like helps you actually take your idea and put it to paper, really, right? Which is amazing. Um, so that's one element, and then there's another element which is one that we've more focused on, which is like the ability to extend your likeness, right, and the ability to create a replica of yourself, so that you only have to record once, and then now you can create millions of videos without having to record them, right? And I think it's a very different targeted use case where we're focused on extending your likeness. I think those are the two different spheres that we see, and both are incredibly compelling, especially if you're someone who's interested in video, or if you want to get into video. And there's been no better time than now.
All right. Now let's talk about the underlying models that are used. Obviously, there are so many different models people have tried. There are variations, but in your experience of doing this and deploying this, what models have worked well in terms of creating just good, high quality videos that they don't obviously fail in like basic things like breaking the laws of physics or having seven eyes? So, what models have worked reasonably well?
Yeah. So yeah, on the novel video generation side, recently I've been really impressed with Kling. It's been a really impressive model that I've been playing around with a lot. Of course, anytime I see insight into Sora and outputs there, those are amazing, and I'm super excited about that. But then on the sort of replica side of things, and being able to create replica videos through your likeness, that's also a very difficult problem, in making sure that it looks like you and sounds like you, and still looks very realistic and authentic. And so what's really interesting is that the approaches for both of them are different right now, right? Creating these novel videos focuses on these very large, diffusion type models, versus creating a replica of you, or an avatar, as some might call it, is based on like neural rendering and Gaussian splatting and nerfs, right? It's creating a 3D representation of you, and so very different ways to accomplish those today. And I think in the future, some of those will merge together.
You mentioned likeness a couple of times. So let's talk about that for a minute. Um, how are today's systems capturing intricate facial movements in real time, and also what technologies are involved to make sure that it looks smooth to the average user?
Yeah. Great question. So on a high level, whenever we're extending your likeness, we're creating a replica of yourself. The input requirements are, for us at least at Tavus, is about 2 minutes of video of you talking, right? And we want you to talk something interesting, because typically the videos that you're putting back out are going to be something where you want to seem excited, right? And we'll get into some of the expression stuff in a minute. But the idea is, from that 2 minutes of training video, what is happening is that the models are learning. They're essentially creating representation between what you're saying, the audio itself, and then the expressions and how you're moving your face, how you're moving your lips, right? And then once that representation is created, it's also creating a 3D model of you using either nerfs or Gaussian splatting, to actually create a 3D morphable model that can then be manipulated. And then finally, it's actually taking in the textures, and putting them into space as well. And then on the output side, then it's sort of almost reversed, right? So what you do is you first generate audio. And the voice cloning models have gotten really, really good these days. But the idea is, from a Tavus perspective, once we have the audio generated, we do audio to expression, right? So then we transfer audio to expression parameters that match your likeness or your face. We put those expressions into this 3D morphable model that then manipulates your face in a 3D space. And then we have, then we are able to apply textures back on top. And then we can run a model that basically ensures that all that pieces together accurately. And so obviously there's a lot of loss functions that determine if likeness is preserved and if textures are preserved. That's like a high level of how it works.
That's amazing. And as a user, as you said, and I come in, I talk for 2 minutes, you capture everything you need to know so that I can create videos of myself saying a bunch of different things, with a bunch of different expressions, different contexts, so that I don't need to keep re-recording the same video, which is fantastic for scale because I can do so many things now. Now, you mentioned 3D modeling. So can you talk about how the data capture happens, especially when you're given a pretty okay most people have okay cameras, like a simple 2D capture camera, and from that you have to extract a whole bunch. So can you talk about the modality of data capture, and also what are all the things you have to do to
Yeah.
extract information from a basic video?
Yeah, absolutely. So a lot of the focus at Tavus, and I think in the industry, has been how can you make it really, really easy to create a replica of yourself, an avatar of yourself? Because the idea of going to a studio where they have many, many cameras around you and you're doing all sorts of stuff is both like prohibitive, right? But also
Right.
just a very time consuming and very stressful sort of situation. And so, the models, especially, as we've seen with nerfs and Gaussian splatting, what has happened is there's a translation layer where you can actually take a essentially 2D video, so just a webcam video, and it's been trained enough to be able to then create a 3D representation, right, through essentially estimation, right? And so it can create a really, really high quality model of you. And the idea is that as you move around, so we ask you to talk naturally, and as you're moving around, it's capturing more and more of your data. And so certainly, like, it probably won't get the back of your head perfectly right, but it can do a pretty good estimation. But if you do turn around, which we don't recommend in the video, but if you do that, then it can actually create that entirety, right? And so, nerf specifically, Gaussian splats, these are very, very good at being able to take sort of 2D video and turning into and from our end, that's all that we require. We try to make it super easy for the end user. So we say, hey, like, you don't even need 2 minutes, even a minute will suffice. And what we're doing then is we have a model that is very, very good at taking in that data. It's trained on a corpus of data on, on like the human form and human faces and everything. And it's able to create a really, really robust representation of you in a 3D space. And so we want to make it easy, and we think that the future is that we want to make it even easier, where it's not even a minute required. It's very, very little time required. So I think it's going to get much, much easier over the course of next year.
You mentioned the terms nerf and Gaussian splatting a couple of times. So maybe quickly, for people who may not know, can you explain what they mean?
Yeah. So nerfs and Gaussian splats are essentially a type of the nerfs stand for neural radiance field, and so they're essentially a methodology to create a 3D form, right? And Gaussian splatting is the newer way of doing it. Nerfs were the first thing, which is essentially you can create 3D form from 2D images. And so it's a way to create a representation. If you ever see like a clay model, that's typically that can be created using one of these methodologies.
Coming back to the likeness and also how realistic it looks, one of the key parts of this is facial expressions. Right? The face movements are important, but facial expressions are also very important because people notice that. So can you talk about how you capture facial expressions for video generation? And also, how does it differ from something simpler like emotion detection versus creating a full video that looks very realistic.
Totally. Yeah. So, I think that, and this is something that we also think a lot about at Tavis, which is, there is this trade off actually between making it easy for you to record and then also having the ability to have a lot of optionality and easy customization of the output, right? And what I mean by that is, uh, is it that you want it to be as close to what you look like when you're surprised? Or do you want it to output surprise without you having to sit there and recording a surprise expression, right? Like that's something that's often a trade-off that we think about at Tavis. But the idea is that people care a lot about keeping they want the video output to look a lot like what it would look like if they said this, right? So, and what's really important is that we all move our faces in a different way for different expressions, right? And so whenever we talk about surprise, well, Hassaan's surprise is a very different form, like because my face is a very different structure and how I actually represent it and all those things, how my mouth moves, how my cheeks move, how my eyebrows move, all are very, very unique compared to someone else. And so in keeping that likeness, it's important to, if you want to keep it as close to reality as possible, you want to try to have that training data. You want to be able to try to, have someone in with a surprise pose or in a like a sad pose. Like I look sad probably very differently than you do, right? But if you have enough data, you can do an estimation of what someone might look like whenever they're sad or happy. It's just about controllability, right? Like where do you lie? Do you care more about the easiness of being able to say, hey, say this in a happy tone, or and it can just estimate that you're happy, or do you want to look exactly like you would in real life?
Yeah, that's actually such a good point here, and it's hard to it goes into the realm of product design in some sense. It's not just about the modeling accuracy. Sometimes a very accurate model doesn't translate to what the user wants or what humans perceive, right? So it's amazing. Okay, now you mentioned earlier how you capture the 2-minute video and then you analyze it and then you create the output. Now in the final step, when the audio comes out first and then everything else follows, can you talk about in the final step how facial expressions are translated in the final video, and also there are subtle nuances that you may have to capture. So how do you ensure the quality, if you will, of the facial expressions, and how do you benchmark it?
Yeah, great question. So on the benchmarking end, I think it's all about evals, right? And creating robust evals that compare to ground truth, right? And ground truth in this perspective is like, if you know what, especially if you have original training data and you know how someone is saying something and how their face is moving, and you can actually then compare it against generated versions of that, and you see how close those things are together. That's a great, very simple eval to say, okay, this model is performing at like a high likeness and high similarity index compared to ground truth. On the side of the representation and making like actually taking in this data and then being able to generate it again for like novel audio. The idea is during training time, as you're moving your face, as you're moving your eyebrows, all those things are converted into expression parameters. And it's sort of on a linear basis, and it's converted into expression parameters that then the model is learning, and it's specifically fine-tuned for you, right? So every time you create a replica, there's a fine-tuned sort of model being created for you, or whether those fine-tuned weights just for you. And it's not just saying, hey, repeat this expression over and over again. It's actually creating a relationship between the words that you're being said, the audio that's being said, the actual tagged expressions for that, and then how you actually manipulate your face. And then for novel audio, once it comes in, the same thing sort of happens, which is like, given novel audio, you deconstruct it and you say, okay, this is what this audio looks like, and this is the expressions that this sort of captures. Now let's actually create new expression parameters that would match this waveform more accurately, right? And then the idea is that the eval again here is comparing it to like ground truth, like how similar is this? Does this deform the face at all? There's deformity measurements you can do. All of those come together to ensure that it's a very, very high quality representation of you.
And I want to spend a minute on the differences between just image generation and a video that you have to produce. So, in many cases, a still image, you can do your thing. The image comes out. It's doable. But in video, you have to worry about things like consistency and temporal coherence between frames. So,
100%.
how do you do it? How do you ensure consistency and temporal
Yeah.
coherence between frames here?
Yeah, so it's a good point, and it's one of the reasons why, thus far, right, like, um, the models that we have in production today, they don't use like a diffusion type approach, right? Just because diffusion models today, they have a speed or a temporal consistency issue. In our case, without diving way too much into details, in our case, the use of creating this 3D morphable model means that essentially, because we actually have like a model of you in this 3D form, and we have this audio to expression model, we can accurately convert like waveforms to expression in a way that's temporally consistent, and then the textures are put on top of that, right? So because of the architecture itself, we don't necessarily have to worry about temporal consistency as much, especially given that like with neural rendering techniques now, you can essentially use that to ensure there is temporal consistency frame to frame. And so it's just a very, very different way of doing it, right? I think that, and that's why, getting into like, diffusion models and how they relate to our industry, I do think that in the future, these will sort of combine together and there will be sort of a convergence in the future. But for the time being, like, diffusion models inherently, will struggle with this temporal consistency issue, which is very, very evident whenever you're trying to create a video that looks like a human.
Going into conversational video, when you want your likeness to hopefully eventually have a real conversation with, I don't know, like if it's a customer support agent or somewhere else, there's like you want it to have a real conversation. So in the videos that you generate, how do you manage things like lip syncing and emotion alignment when the output comes out? And also, what are all the things you have to sync in the first place? I know it's not just like video and audio. There's other things. So what do you have to sync here?
Yeah. Yeah, so for conversational video, it's like you take video generation. You're like, all right, let's just 10x this problem, because you have to do it like, with video generation. You're like, okay, if it's not fully real time, you're okay. Now you have to do everything, but you have to do it in real time. And there is a little bit more forgiveness because it's only one frame they'll see. They can't replay it too many times over and over again. But nonetheless, the models that we create for video generation are actually the same models that are power conversational video for us as well. And so the similar problems, they're the same problems apply. But the difference is you have a lot less time to do all those things. And that's where the complication comes, right? You have a lot less time to do any form of audio generation. You have less time to actually do because in about 500 milliseconds, you have to both transcribe audio in, figure out what that audio is, using an LLM or some sort of language model, figure out what the output needs to be. Then you have to create audio from that. Then you have to put it into this real-time replica thing, and you have to get the first frame out in 500 milliseconds, right? And so all of those things have to be actually orchestrated very, very closely together. So I think the thing about conversational video is that for a high quality experience, all of these modules have to be very, very tightly coupled together, right? You essentially have to like really optimize for inference here. And so it's a very different problem set. We have to worry about very different things, often than video generation, even if it's the same model powering.
Yeah, it's a great point. It's like you take all of the problems of video generation and you 10x it, and you get
Exactly,
you get to you
exactly.
get to face conversational
The good thing
video. Okay,
is that
yeah,
video conferencing over WebRTC is limited in resolution, so you can't see everything in 4K. So there are
right,
some wins
right.
here.
Right, no, 100%. Now, you mentioned inference, which I think is a great next topic to dive into. Now, inference becomes a lot more relevant in a setup like conversational video. So, just in general, when during the inference stage, video generation or real time conversational video, um, during the inference stage, what what challenges do you have to deal with when it comes to just inference, just in general?
Yeah. So, you know, on conversational video specifically, I mean, this is also true for video gen, but on conversational, I think from the biggest thing you have to worry about is being able to generate frames faster than real time, essentially. Like, and so let's say that we output at 25 frames per second. You have to be generating at like over 30 35 frames per second. And what that requires is it requires like pretty a pretty powerful piece of hardware, right? And so like it's not something you just run on A10s; it requires A100s. And then also, there's so much memory optimization you have to do, fitting these models on all these things because it has to be all tightly coupled together. You really have to. You're sort of running this all, locally, right? And so all of those things together create a infrastructure challenge for sure, an architecture challenge. But then also it's like these models have to be hyper optimized, right? So the difference between video gen is video gen you can take a little bit longer and you can say, hey, I'm gonna take a little bit longer because I want higher quality, or it doesn't really matter. Like what's 300 milliseconds, right? It doesn't really matter. But for conversational, like 50 milliseconds is a massive add-on. That we're measuring 50 millisecond differences. We're measuring 10 millisecond differences whenever we do something. So it's a very different game. But the most important thing is being able to generate frames faster than real time.
And earlier you mentioned kind of like the pipeline in conversational video where audio goes in, this audio in, transcription, understanding it, then creating a text response, then creating audio, and it goes on. So between that, during that process, what is the biggest bottleneck? Or rather, if you had to arrange them in like descending order of like, hey, this takes the most time versus the second most, what are like the top three?
Easy answer is an LLM. Is like especially if you're using your own LLM. Easy answer. At Tavus, we've optimized every other step to be really, really, really fast. And so in like, let's say in like 600 milliseconds, probably half that is just the LLM, and that's probably a fast LLM. Most people's LLMs are really, really slow. And I don't think there hasn't been there is more so now, but historically there hasn't been a massive focus on what makes for a really fast LLM for this use case. People talk about like tokens per second, and sure, that's really great. But what really, really matters is time to first token, right? Because if your time to first token is long, then it doesn't matter how fast you can generate the rest of it. It's going to take a really long time for that first one to come back. And so the LLM by far is the worst offender today, and why often we have to work with our customers really deeply to be like, hey, we need to figure out how to optimize this because we don't want to wait 2 seconds for a response.
Right. No, it's very interesting because if you ask the average, if you conduct a survey and ask them, hey, there's a thing and it has text, audio, and video, what do you think takes the most time in this pipeline? They'll say video, because historically video has been like, you need so much compute. But in this case, LLMs are like the biggest blocker,
Absolutely.
which is very, very interesting. No, is a solution to that a very custom, very small, use case specific trained LLM? Like what needs to be done here
Yeah.
to remove that blocker?
There's a few things, right? One is absolutely like smaller, more domain specific LLMs that can really optimize for time to first token on optimized compute. I think the challenge that comes is that uh, we're not like we're providing this technology to developers, and developers already have their own LLMs that are trained on corpus of information, and so us providing a very, very small LLM, which we do, right, doesn't always work because people have very custom use cases, and so their LLMs end up being a little slower, right? But I think the actual longer term solution to this is that these pieces don't need to exist separately; they actually need to exist together, and it's something that we work on at Tavus. And so what that means is like we already see this. We're seeing this with voice to voice models, and there's not many that are really, really that amazing yet. But if you can actually reduce the amount of conversions that you have to do from one modality to the next, that really optimizes the latency, and that really optimizes the time it takes to generate an output.
Interesting. And if you do build a multimodal model like that, and on one hand, the coherence, the speed increases. What are we? There must be a trade-off. Like, what are you giving up to achieve that speed? Is it do you have to buy bigger hardware, more compute? Like, what are you giving up to get there?
Controllability is what you're giving up primarily today, at least, right? Right now with these different modules, you have a lot of control over each of these modules, and they can be trained in a very specific way. Whenever you try to combine all these together, you lose a degree of controllability that you had before, right? Like you can't, there's a loss in converting from one to another, but there's also control where you can intercept and say, okay, that doesn't look quite right. Let's do this before we transfer to the next step. And so that controllability is what you really lose. And I think that's going to be part of the challenge, right? Especially because like it's one thing if if we talked about hallucinations, right? Like, if an LLM hallucinates text, well, there's Llama Guard and all these guards that you can put on top that sort of checks for these outputs. Now, if you remove that representation that converts from text to audio, well, now it's all being done more so in this like latent space, and so it becomes a little bit harder to do some controllability. So that's what you lose in the process, which is going to be a trade-off for sure.
Moving on to from the product to the business that you're running. No, more broadly, video API business. Historically, API it's been a phenomenal category of businesses to run. People consume it. The more they consume, the more they pay. It's a great business model. Now, having done this, you've done this. What are some of the things you'd advise other founders who are running API businesses, not just video, but any API business? What are some of the things that they should do? And also, more importantly, what are your learnings on things that don't work or people shouldn't do when they're running an API business?
Yeah. I think focusing on the developer experience is like the most important thing that you can do. And I think on that note, like considering that the developer experience is your product, if you're an API company, right? Like it isn't like docs aren't this separate thing that you do. Docs are the product actually. And creating a really good experience is your product. And so if you're starting an API business, I think that's the most important. I think that just like having the API, even if it's like the most amazing API that everyone wants and just like putting it out there, like sure you can, that might work, but ultimately if you really want to have people build deeply, especially as like we've seen a lot more concerns recently around like platform risk. People are like, they don't want to rely on OpenAI for everything and all these things. Like building this really great developer experience is paramount to building a long-term like API company that sort of stands the test of time.
Right. That's a great point. And also any pitfalls to avoid. Through experimentation, maybe you've discovered things that what have you tried and things that didn't work.
Don't overwhelm people, right? Like I think that people, like especially like two things. I think don't overwhelm the customer, even if they're developers. Like just like throwing a bunch of stuff at them and saying create something often results in like it being very difficult to create things. You do have to have a little bit of incremental disclosure, and you have to showcase like, hey, this is how you can build this thing, and then this thing, and then this thing, because otherwise, like the assumption that someone else will understand everything that's in your head and be able to build what you're thinking is like a common pitfall that I mean we fall into in the past, because we're like oh, let's just release everything, but it's like, okay, actually let's take the time to like help prescribe a little bit about how you could use these different things. So that, and then the most important thing is like focusing on reliability and stability, right? Which like, it's there's this concept of like moving fast, like in Tavus, like we always talk about moving fast. But often, what's not considered is like, well, there are certain things that you can do to set yourself up to move faster, even if it means being a little bit more thoughtful right now. So
Right.
those are two things I would say.
Yeah, no, that's amazing. I think especially the first point you mentioned is such a good point, because many times I see the young founders, first-time founders, they build dev tools and they have some basic documentation. And if things are stalling or not working, they think, oh, the solution is to write much longer documentation, add a lot more details. Paradoxically, funny thing is, if things are not working, you go in the other direction. Meaning, it's like famously what the Collison brothers did for Stripe. If they literally they showed up at the door and say the solution is we'll do it for you, white glove service. To forget the documentation, we'll sit next to you, do it for you until it installs. The solution was not creating more documentation, because at that point in the early days, people, they don't really care about you or the product, right? So it's a great point you mentioned here. Yeah.
And I think that building with your customers is so important, right? And I think that's like also like I think often the thought is like, oh, it's a SaaS business. You just give it to people. You don't have to give any support, because like Google
Right.
doesn't give support. Why do I have to give support?
Right.
Right. Well, it's like, oh, just give a
Right.
Discord channel and like, people will discuss. But actually, like, on the point of Stripe, like that is still true today. Like helping people build, helping people figure out like what to build, like really being their partner. And at Tavus, like what we like to say is like our customers consider us an extension of their team. And that's the
Right.
best thing that you can have happen for a company, is whenever your customer feels like you're just part of their team.
Right. And funnily enough, even for a company like Stripe, very customer obsessed, their documentation, I think, is the world's best. I mean, for a long time, that was like the gold standard of how do you document a dev tool. Look up the Stripe, and they're the ones who are providing the best white glove service too, on top of the world's best documentation. So that's something to, yeah, that's fantastic. All right. I have one final question before we go to the rapid fire round. Now, today, so many breakthroughs happening, so many things in AI. What technological breakthroughs in AI are you most excited about?
Yeah, that's a great question. I'm really excited for the next generation of multimodal models that are coming from open source. So specifically, I'm really bullish on the Meta Llama team. I think they're doing. I think they are single-handedly accelerating progress in our industry a crazy amount. So I'm super excited. Like that's the thing I'm most bullish about.
Amazing. Yeah, I agree. I think that was a fantastic change of direction. It's landing really well for Meta, the company, like going from VR to now they're like the champions of AI open source, leading the good fight. All right, so it's amazing.
Exactly. And it was all this, like there was so much questioning. They were like, oh, Zuck doesn't know what he's doing. Why would he open source? How will he ever make money on this? Like, in the investor relations calls, like people are like, "Will we ever make money?" He's like, "I don't know, maybe not." But now it's become clear that like it is completely transforming the industry, right? Like,
Yeah.
what a good bet.
Yeah, no, amazing. And also, I recently read something where people are wondering, like, hey, what's the ROI? As you mentioned, like, they're asking big companies, Facebook, what's the ROI on all the investments you're making? Where's the money? And forget the ROI. The fact that they're building and deploying these models, the tiny incremental ad targeting they can do, they've already done with this, has already returned the capital. So so people are not looking at that, the internal improvements on all this insane AI capabilities they're using to target better. They've already gotten their money back, and now they're just like doing it for extend their advantage. So yeah, 100%. Yeah. All right. Great. With that, we are at the rapid fire round. I'll ask a series of questions and would love to hear your answers in 15 seconds or less. You ready?
Yep, let's do it.
All right. Question number 1. What's your favorite book?
Go Like Hell by AJ Baime. It's Ford versus Ferrari Le Mans battle book. Very
Amazing. Yeah, I love that whole story, the movie too. Yeah. All right. Next question. What has been an important but overlooked AI trend the last 12 months?
Yeah, we talked about this briefly, but like how specialized small models on very optimized compute have made multimodal conversational AI like incredibly immersive and low latency.
What's the one thing about video generation that most people don't get?
The complexity and nuance in getting realistic video. We often see people always go for like high-end studio production in front of a green screen, and it just looks really bad. We always say webcam wins. It looks authentic. It's what people expect.
What separates a great AI product from a merely good one?
The obsession over the small details, like focusing on the user experience, especially for those that are new to using AI, right? So that's the most important thing, I think.
What have you changed your mind on recently?
AI therapy. I was pretty against it at first, but now I think it will allow people to be way more vulnerable and honest, and give way more people access to therapy.
What's your wildest AI prediction for the next 12 months?
We'll be talking to AI digital twins every day for various tasks, and it will be completely normalized.
Amazing. All right, final question. What's your number one advice to founders who are starting out today?
Don't fall into the hype trap. Focus on building a great product with a strong foundation that you have conviction rather than trying to like get viral, right? Like heads down and build. Everything else is a distraction.
Perfect. Hassaan, this has been a brilliant discussion. Loved the details on both the product building, AI, but also the business side of what does it take to run a real company, because there's product design, users, customer obsession, all these things come into mind. So thank you so much for coming onto the
It was a
podcast
lot
and
of
sharing
fun.
your insights.
Yep. Thank you so much for having me.
Perfect.